It's been our pleasure at Dialog to meet Sam, James and Shaquil several times over the last 18 months as they started out with the introductory course to APL and then visited us to play with robots. So, without further ado, the mice who once were blind from Optima.
Hello everyone. We're here today to talk about our Raspberry Pi projects, so I'll begin. So I'm Sam, this is Shaquil and that's James. We come from Optima Systems in the UK. We have been working there for just over a year now. We were apprentices last year and now we're trainees, so we're fully fledged now. We've been using APL for just over a year, so we're still relatively new. And we started a blog last conference for those of you who are there, and we try to keep it up to date as much as possible. So, a bit about the project. Last conference, Morton and Co were talking about Dyalog APL on the Raspberry Pi, and they got us to thinking we could probably work with that. And then Morton started building a robot, and we got a bit jealous. So, Paul Grosner, Managing Director at Optima Systems, said this might be a good idea for a project for us. So he then asked us to investigate it and to show our findings. He then budgeted for a project for us to start playing around with it. Our budget was about £150. We had until August to finish it, and I think we started in May. So we each chose individual projects to undertake. I chose a weather station, Shaquil chose a car, and James chose a robot. The Raspberry Pi and all of its hardware were the main objective to get it all working, connected up. And James is now going to talk to you a bit about the hardware.
Right, so I'm going to talk to you about the hardware today. As you can see, we have a lot of gadgetry. The basic recipe for a Raspberry Pi project, what you're going to need is obviously the Raspberry Pi, the SD card that holds the operating system, and you're going to need an Arduino if you want to do anything with sensors and the like. So I'm going to move on to the next slide. The most important part, the Raspberry Pi. So the Raspberry Pi runs a Linux operating system called Raspbian. So that's optimized for ARM chips. So it runs on ARM chips instead of Intel or AMD. It runs Dyalog 13.2, and they've just sold their millionth Raspberry Pi, and it's made in Britain. So that's quite impressive. So the Arduino, that's what we use for a basic input-output device, and we use that for sensors and communicating with our motors and other things. Okay, so software we use Linux, as I said before. We use Dyalog 13.2, which is on the Raspberry Pi now. You can get that from the Dyalog website. And we use the Arduino IDE. That's how we program the Arduino and put the C code on there that the Arduino uses. And other software we used was Putty. Putty is an SSH client, and that allows you to communicate with the Raspberry Pi from a normal computer. And we use Samba. Now, Samba is just it's a protocol that allows you to transfer files between different computers. Okay? So I'm now going to hand you over to Shaquil, who's going to talk to you about problems.
Thank you, Sam, James. So with all this hardware, you can imagine we had loads of problems. I'm wondering, how many of you have worked with the Raspberry Pi, a part of Morton and the Dyalog team? Only three people, it's 4, 5, 6, okay. Well, I'm just going to talk you a few problems we had, and you probably had them as well. So the first two problems are soldering the Arduino and reprogramming the Arduino. So as you can see, the Arduino is really small. It's a little chip that we had to solder to, and the holes were really, really small. And none of us had actually really good experience soldering, so it made it hard for us. With that, reprogramming the Arduino. So as James talked about, the Arduino contains the I2C code, so that's the C library that Morton helped us with. And that got updated, and we could not reprogram our Arduino with it. Well, the third problem was wiring. So when you do a project, you want it to look nice and neat. In the first 2 months, it looked horrible, as you can see there. I didn't like that at all. So that was one of the problems we had. I never had done wiring before, so it looks better now. You'll soon see it. Well, another problem we had was we needed a big base to support all of our robots and the components. As you can see, that is not good enough, is it? It's not going to fit everything there. The next problem we had was SD card corruption. So we had two different problems with this. So the first one was on my Pi, we tried to get live streaming working. It all looked nice, we installed few plugins, it was all looking good. However, it asked me to reboot the Pi, and I say, okay, fair enough. I rebooted the Pi, it never came back on. So just don't install plugins on a Pi. The second problem we had with SD card corruption was with James. His Pi wasn't on for probably 2 weeks or so, and when he tried to get it on, it was just not coming on. So just make sure you turn your Pi on every so often. Another problem we had is power problems. So basically, at the moment I'm running my robot off cables. The problem is the batteries I have are not good enough to power the Raspberry Pi and all the other components. So at the moment I have to use cables for it. I will now hand over to Sam, who will talk about his project, the Pi in the Sky.
Thank you. So, my project, as I said, was a weather station. I thought it was a clever name to call it Pi in the Sky. I have no idea why. My objectives of this project were to make something I had an interest in and to make something that had a use. So I decided to do a weather station because I have a strong interest in weather. So the main objective was to get at least 3 sensors working with the Pi, and obviously they would be weather related. So I managed to get a temperature, humidity and light sensor working with the Raspberry Pi and MiServer. I store the 3 readings into a DCF file and then used RainPro to display them on the MiServer page. So this is just a quick circuit diagram that I drew up just to make everything a little bit clearer. So as you can see, there's the Raspberry Pi, the Arduino, excuse me, the temperature sensor, humidity sensor, and I used a light-dependent resistor for the brightness. So here's a system flow diagram of just how it will work. So as you can see, I've got the user there interacting with the interface, going into MiServer, which is APL and HTML, onto the Pi, which is also APL, through to the Arduino and to the sensors, which would then read back through and flow both ways to give readings and get readings. I'll now hand you over to James to talk a bit about his project.
Thank you very much. Okay, so today I'm going to talk to you about Private Pi. So you might be wondering why I was going to call it Private Pi. Originally, I was going to have a USB missile launcher on top, controlled by Raspberry Pi, but that was deemed too dangerous, so we didn't do that in the end. But anyway, as you can see, here's a diagram of how my Private Pi works. So you've got the Raspberry Pi, which is attached to the Arduino, so that sends information via APL to the Arduino, which uses C code, which then sends commands to the motor controller, which powers the motors, so I can go forwards, backwards, and whatnot. And how this is controlled is through MiServer. I think people have already spoken about MiServer. So you can control that on any web browser, phone, desktop, tablet, and it all works. And now I'm going to show you the first maiden voyage of my Private Pi. And you might not be able to see it over there. And I should have implemented stop button. Thank you. Okay, so I'm now going to hand you over to Shaquil, who's going to talk to you about his racing Pi. There you go.
Thank you, James. So here's my project. As you can see, a few pictures there. So the racing Pi, what is it, how it looks like? So you can tell it how it looks like, but what is it made of? So first thing, I wanted a robot with 4 wheels. Now you've seen robot with 3 wheels, 2 wheels, and the Bulgarian. I didn't want anything like that. I wanted to make something different. So we got 4 wheels there. How does it work? The back 2 wheels has 2 motors, and that basically just goes forwards and backwards. Now, the front 2 wheels has a servo, and this is how the servo works. It's basically turning left, right, and then it's going to go to the center. There you go. Now, I wanted the distance sensor at the front as well. The distances I've got at the moment is not really good. It basically just emits sonic waves and gets back to me saying this is how long it took to find something. I don't like that at all because it's not really reliable. So if I could do something better, it would be buying an infrared sensor. And that's where the distance sensor is right here. So next one up is the Pi camera. I wanted a camera so it can record where the robot goes. So if it goes there, it can take a picture and so on. So I wanted something to take a picture and display it on a browser. And that's how I control my robot, through MiServer. Now, we got the PC version, so if you have a laptop or a desktop computer, that's what you're going to see. If you got a phone or a tablet, this is what you're going to see. Not much difference, but you can also control it on a phone or tablet, and that's why I wanted to control it through MiServer. Now, probably I should show you a diagram to see how things actually work for you to understand better. So we got the Raspberry Pi that has the APL code and all the commands. We then have the Arduino that has the C code that we have explained to you before, and all the APL code has to go through a part of one thing that I'll show you later. So what does the Arduino do? It will send information to the motor controller, which will basically send the robot forward or backwards. It will tell the servo to turn left, right, or to go straight. And it will tell the distance sensor if there's anything in front of you. And the Pi camera, that was I was talking about, goes straight from the APL code because it's just a Linux command. Now we will show you how our projects actually work and how they actually are live. This can go really wrong, but fingers crossed, this will go everything will go right. So I'll pass it to Sam.
As Shaquil said, everything can go wrong, so expect it to. So I'll just open the MiServer page. As you can see, it's my weather stations page. I've just basically put a bit of branding on there. Title. It's very simple HTML. I didn't get too experimental. So as you can see, at the bottom I have two buttons saying get readings and one saying get graphs. So if I click get readings, there you go. So it's usually only about a degree up, but it looks like about 10. So if I just click get graphs now, it should display 3 graphs. So as you can see, it's for the past 7 days. So there's the temperature. There's the humidity. And there's the brightness. And that is my project at the end of a very short period because it was pretty easy. So I'll now hand you over to James to do his demo.
So this is a MiServer interface. Obviously, as I said, well, as Shaquil said, my SD card was corrupted about 2 weeks ago. I lost everything, so we had to start completely from scratch. We also had a lot of other problems. Last night, it wasn't working at all. But Jason actually came to my rescue and has helped me out a lot, so thank you for that, Jason. However, he did set my Pi on fire. And my Arduino. But he gave me a new one, so it is now working. So I'm going to show you it going forwards. I have a duck. And I'll just show you it on the floor, because we can control it by anything. So I'll go on my tablet.
Yeah, I think it's because of the carpet, really. So, well, as I said, come towards the break and you'll probably see it better. Yeah, you'll have a go at yourselves. Careful. We can move on. So, as you saw the desktop version, I actually wanted to show you an iPhone, but because we don't have the camera working at the moment, after break, probably you can come to us and you can see it better. So, this will be really tricky because, as I said, I've got cables all over there. So I'll ask James and Sam to move a bit. So I'll just tell the robot to go forward and to turn right because I want it to face the audience. And as I said, I can take a picture and display it there. So if I take a picture, and there you go. That's the conference. So this is how my project works. As I said, if you are really interested, come to us at break and I'll show you it better. And you can also control it yourself on my phone, on the tablet, on desktop. Okay. Now, we would like to thank some people. And that is Jason Rivers for getting everything working with us. Thank you, Jason. We would like to thank Morten for the C code and for the help with the APL code. We would like to thank Liam for the Pi, to getting the Samba working party, as James explained. And of course, we would like to thank Paul Grosvenor and Optima Systems for taking us to the conference and giving us a job in August. Thank you, Paul. Right, thank you for listening. Does anyone have any questions at all?
How would you extend projects? What else would you do with more time and cash?
Okay, so he's asking if we probably could do something better, if we could extend our projects, what would you do? So I'll start with myself. So as I said, if I could do it better, I would have an infrared sensor. So basically that would be more reliable and my robot could be more, it could be basically running automatically. And that would be the first things I would change. I'll now pass over to James, who will tell you what he's going to do better.
Thank you, Shaquil. So what I would do differently, I would have more sensors. I would have a USB missile launcher, obviously. Other things I would do differently, I would take backups regularly, which everyone should be doing. And I'll pass you over to Sam, see what he was got.
Well, I'd add a few more sensors, but because we had a £150 budget, I couldn't afford to go and buy a wind gauge and some really fancy sensors. So if I had a bigger budget, I would have done that. I would actually like to make the graphs more customizable, possibly even scrollable, so you could go through more than just 7 days. I think that would be a good improvement. Any other questions?
Seems not. Thank you very much.
Thank you.